Here's 2013 question 1. This is an accumulation problem. This involves unprocessed gravel arriving to a plant, and then they talk about how at the plant this unprocessed gravel is being processed. So there's a lot of things going in and out at the same time. So we have a rate in and a rate out type of problem here. So some things to note: the amount that's going in is measured by this rate g of t right here. Now normally there's another function, but that out function is actually going out at a constant rate. This will occasionally happen. That's just saying that this constant rate here is really just 100. It's constant. It's not changing. So just keep that in mind too. So here we go. Part A, they're asking us to find g prime of 5. That is probably the most straightforward question here. You have g, you need to evaluate g prime of 5. So once you program g of t in as y1, all you have to do is go to your home screen, math 8, d over dx of y1, and evaluate that at x equals 5. This is a quick plug and chug, okay? So if you notice in the scoring guidelines, you get 1 easy point just for the plug and chug, okay? So you should get negative 24.588 or 587 if you truncate. But they also ask you, using correct units, interpret your answer in the context of the problem. So a good measure to do, we just figured out that the derivative came out negative. Remember the implications. When a derivative comes out negative, that means the original function is decreasing. Now we need to give it some context. Now what the heck is g? Okay, so if you read g back in the problem, g of t is already a rate at which the unprocessed gravel is arriving. Okay, so we know that the rate at which gravel is arriving, that is your g right there, is decreasing by that amount. Now, since g is already a rate, g prime is going to be tons per hour or tons per hour squared, up to you, at t equals 5 hours. So you really need all the components here. The only way to get good with that interpretation is to just practice it. Okay? Keep practicing over and over. See what you're missing and see what you seem to be retaining each time. Part B. Find the total amount of unprocessed gravel that arrives. So that's probably the key word there. During the hours of operation. So we have a function, g of t, that represents the rate at which unprocessed gravel is arriving. So all you have to do is get rid of the word rate. And the way that we do that is to integrate. So we just have to integrate g of t from the hours of operation. In this case, it's going to be from 0 to 8. Now, we don't have to consider how much we started with because they're asking you what's the total amount that arrives. So we do not have to consider the amount that we actually started out with here. So just keep that in mind. So that was a quick plug and chug. Notice how you get a point for the integral and you actually get a point for the answer. They don't ask for units, so you really don't need tons there. Sometimes the scoring guidelines just give you a little bit more than you need. Part C. Is the amount of unprocessed gravel at the plant increasing or decreasing? So the amount of unprocessed gravel. So notice how it doesn't say arrives or leaves. So it's just in general, the amount of unprocessed gravel. If we want to know if it's increasing or decreasing, we have to check its rates. Okay? Because if the rates are positive or negative, we will be able to tell if the amount of unprocessed gravel is increasing or decreasing. So many ways that you guys could do this. The scoring guideline found out what g of 5 was, okay, which is the rate at which unprocessed gravel is arriving. Now we know that gravel is being processed at a constant rate. If you look at the last sentence here, at a constant rate of 100 tons. So if we assume that they're just breaking this gravel down, okay, that's kind of like your out function. G of 5 came out to 98. So the amount that they're processing is 100. So since that rate that is coming in is less than 100, we know that it has to be decreasing, okay? Now, some people might do it like this, G of 5 minus 100. If you actually do G of 5 minus 100 on your calculator, you will actually get something that is negative, less than 0. Now, if G of 5 minus 100 came out positive, you know that there's more coming in than there is coming out. But either way, it doesn't matter which way that you guys compare it. Since it's less than, or since the whole amount is less than 0, we know that the unprocessed gravel has to be decreasing at that time. Okay? Part D, last one. What is the maximum amount of unprocessed gravel at the plant during the hours of operation? So, key word here is maximum and during the hours of operation. So we're actually looking at an absolute max, not a local max. This is where it takes a little bit of time, but here we go. We right away know that it could occur at the endpoints or at a critical number. Okay? Now, to set it up, the amount of unprocessed gravel, you're going to go from 0 all the way up to some specific time. Okay? And you're going to integrate the rate that goes in and the rate that goes out. Okay? Now, if you're trying to figure out the amount of unprocessed gravel, this is just how much that's accumulated, but you have to consider what you started out with. So at time 0, if you read in the problem, it tells you that the plant already has 500 tons to begin with, okay? So this is pretty much how we come up with this equation here. Now, if you want to find out where the derivative is 0, you take the derivative. Notice how when you take the derivative of 500, it's a constant, it goes away. The derivative of an integral is really just a function that's on the inside right here. So that's a prime of t, you set equal to 0. You can find this in two different ways. The easiest way is to just graph it. I already have y1 programmed, so I would probably go to y2 and call it y1 minus 100. And then I would just graph y2 and not graph y1, okay? Once you graph this, you're looking for where the graph crosses the x-axis so that you can find your 0. You would just have to calculate it by going to second, trace, 2, and then find your 0, pick an appropriate left and right bound. It really doesn't matter if you guess, but if you did it right, you should have a 0 at 4.923-ish. which is your critical number. So I'll put that in here, 4.923. Now, you shouldn't round it because it's not the final answer, so just keep that in mind, okay? So you're trying to find out where the amount is the largest, so you have to plug it back into A of t, which is what we had up here. Okay? So, two ways that you could do this. What I would probably do is I would type out 500 plus, this is where I'm at my home screen, the integral from 0 to, in this case, my first value is 0 of y2 dx. Okay? My second one would be the integral, 500 plus the integral from 0 to, now I'm going to use my critical number, 4.923480, or you could store that value if you want of y2 dx. And then you would do it one more time with that last value, 500 plus integral from 0 to, in this case, it's 8 of y2 dx. So with a calculator, it doesn't take very long because it does everything for you, but you should get these values right here. You notice that the largest value occurs at t equals 4.923. But let's read the question real quick. They're asking you, what is the maximum amount of unprocessed gravel? So you wouldn't say that it occurs at t equals 4.923 because they're not asking you for the time. They're actually asking you for the total amount of tons. So in this case, you would just use 635.376. They don't ask you for units, so no need to put tons there. But your justification is basically your table. Okay?